Hello, let's take a look at a worked example of timber roof ties in ClearCalcs. So to do so, we're going to use a wood roof tie, ASD, and our collar tie template. So the example that we're going to be looking at is a gravity loading only example, and you can find this help page and the full printout at support.clearcalcs.com. So this example is designed to have the following inputs. We have a total roof width of 17 feet with no eaves, total roof height of 6 feet, a tie depth at mid-height, which is 3 feet, and we have a dead load of 20 pounds per square foot, snow load of 35 pounds per square foot, and a tributary width of 16 inches. So this example has a few things that we'll have to convert, so we'll do so in ClearCalcs. To start, we have our rafter plan length. We wanted a total roof width of 17 feet, so we're going to do 17 divided by 2, and we can get the 8.5 value right up here. Next, we have our roof pitch. We wanted a total roof height of 6 feet, so to get our roof pitch, we're going to calculate rise over run, which is 6 divided by our rafter plan length, which is 8.5 feet, and then we'll multiply that by 12 to convert our units. The depth of our first tie we wanted at mid-height, which is 3 feet. And then for our plan length, that was 0 feet, and our bearing length is good to be kept at 3 inches. For our rafter member, we are going to use a 2x10 hem fir with a number 1 grade. So using our member selector, we'll put in a 2x10, and we're looking for a hem fir with a number 1 grade. And for our first tie, we will use the same hem fir number 1 grade, but we will use a 2x4. So for these members, we can also use the auto size feature that we have. However, we can only do this if we had already configured the preferred sections in our project details page over here. So next we have our loads, and we have just a roof load with a tributary width of 16 inches. So I'm just going to delete these for now. And for our tributary width, we wanted 16 inches, and currently we have 1 foot plus 4 inches, which works out to 16. So we're good to keep that as is. We'll leave our orientation as gravity, and we'll account for the incline in our inputs. So we have a dead load of 20 pounds per square foot, and since this value is over conservative, we'll multiply that by the cosine of the incline. And for our snow load, we'll do the same. We had 35 times cosine incline. Now for our self-weight, we can ignore this since we already included all of that in our dead loads. And for our design conditions, we have slightly different values than our project defaults that were indicated in the example. So for this one, we're just going to input 240. Now, if we scroll back up to our summary, we can see that our design is passing and the axial load for the tie, as well as bending moment, shear, bearing load, and deflection is calculated for the rafter.